Hello, welcome to ZenView Studios Lab. Eric here. So today is a following video. It's the second video about capacitors. I made a small video about the LCR meter I got recently, but I want to go over capacitors, mainly electrolytic capacitors. There's some other failures. Film capacitors fail also, older ones specifically, but one of the biggest deal is with electrolytics. The reason being that it's not so easy sometimes to say if it's good or bad capacitors when their shape is not good, and we'll see it. I will show you in the zoom. It's easy to see if it's bulging and to determine that there is a problem. But sometimes you have capacitors which have no external signs of problems, and in fact then it's only technical measurement that will tell you whether or not the cap is good or not. And since this is one of the things that you, especially in audio, might change very often, and that will also create problems. I just wanted to make this video. Many have been done, and I will put links as to a lot of material that you can find on the web that explains things about capacitors. However, I never found such a very clarified step-by-step approach, and that's what I will try to give a little bit in this video, specifically about electrolytic capacitor. So let's go about it. So this is now about building a sense of what's good and what's bad. One way is to learn yourself about the values without a table that ought to be good. Here we have a 470 microfarad cap, and we can see 90, so 0.89 or so 88 milliohms, and the dissipation factor is 0.21. Okay, always another 470. This is, I will give you the voltage also, and now we have the ESR is 77, and dissipation is 0.19, 0.20, and 412 microfarads. That's for 470. So you see, from one cap to another, it varies. But let's see another brand. These were 35 volts caps. You can see in the same brand, before we go to another brand, 470 micro, but with 25 volts. See, now we have, whoops, about 80 milliohms. Oops, sorry if I don't make good contact. 80 milliohms, and it's 0.19 the dissipation factor. 0.73 milliohms going to 85. It's moving a little bit, and it's 406 microfarad. Okay, so if you remember, the same brand but 35 volts, we had a little bit more dissipation, 0.22, 0.21, and a little bit higher ESR, 0.87. If we go to a 16 volt, that's the same 470 microfarad, we have an ESR which is much higher, 0.200. I mean 200 milliohms, sorry, and dissipation factor which is way higher, 0.49. These are new caps. We compare to another one, 200 milliohms and 0.52. So this is all right apparently for this cap, because two have kind of same value. But you see the big difference between 16 volt and 25 volts? The dissipation factor is only 0.19, much better. And the milliohms is 75, 1/3 ESR. So this cap compared to this cap has an ESR which is almost 1/3, even though it's new. So it all depends on the shape and the size of the can and everything else, and the manufacturer too. I'll show you between manufacturers too. 200 milliamp and 49 for the dissipation factor. These are all 470 microfarad caps. 16 volts, 25 volts, 35 volts. And this is another brand, 470 microfarad, 50 volts. Actually, it's from the same maker, I think. Not the same kind of caps, but yes, it's the same maker. But here, if we measure, we get 75 milliohms, so quite very good, and dissipation factor 8.18. Okay, so tendency is that when it's bigger, it's better. Let's see here. We'll have another example. This is a big name cap, 220 microfarad, 25 volts. That's high quality caps. And you can see it directly from the values. 0.93 milliohms for the, 93 milliohms for the ESR and 0.124 for the dissipation factor. Those are 220s. Just for comparison, we check another one, it's all brand new, 93 and 0.120. Same thing. Now, see the size? It's the same capacitance, and it's 35 volts. This is 25, but much bigger. So the only difference is that this is not the same size. Okay, well here the dissipation factor is 0.24 and 200 milliohms. Okay, remember? This was 89 milliohms and 0.1, and it's even now better, 1.1 dissipation factor. So it's twice as good in terms of performance, even though it's the same, same type of capacitor, theoretically. But as you see, when you have a bigger can, you can afford, and it's from a good brand, you can get better results. So it gives you an idea that with little differences in size and voltage, you get different results. This is why it's not so easy. Everybody says, well, ESR and blah, blah. But the reality is that you have to build a judgment. One way is to compare with new capacitors. Okay, this is 199 milliohms, 196 milliohms, and 0.1 dissipation factor. This is high quality again. And that's, I forgot to read what was the microfarad. It's 240, let's see, it's 95, so it's 100 microfarad cap. Let's have a look at a lesser brand. Sorry, this one. Probably the battery is coming to be a bit low now. Okay. Here the cap says 88, but it's 235 milliohms. Dissipation factor is quite good, 0.12. So even though this is 100 micro also, let's see for sure. It's very small prints. I can't read it. Let's see. Yes, 35 volts, 100 microfarad. So again, this reads 200 milliohms and 0.12 dissipation factor. So these are between the 100 of high quality and the 100 of lesser quality. We get very little difference. In fact, you see, in this case, for the 100 microfarads, almost no difference between this one and this one, even though it's different sizes. So this is all to show you that it's not that easy and simple to judge. And you have to build up some experience on that. And ESR is just not a straightforward measure. This is all assuming that this is correct, okay? Again, and I'm not changing the frequency or the voltage that I'm using. This all across, as you've seen, I've not touched anything. 53 milliohms and dissipation factor 0.28. That's for 1000 microfarad, supposedly, and you see it's 850 microfarad only. Another one, it's all brand new, 0.56 and 0.28, okay? So these seem to be all right values for these caps. 831, 0.57, no, 57 milliohm and 0.30 dissipation factor. Okay. Now let's look back at those caps, which I said were failed. Why did I say they were failed? Aha. Okay, if you look at our ESR, you get 150 and so milliohms, so it's not that big, and the dissipation factor is 333 or 32. Okay, now I take this again. That's the same one, 150, same one, but it's the one which is bulky. 150, 160 milliohms and 340, 376, 363, okay, 0.36 something dissipation factor. Now I will show you something. This is the board where this is the one which was working. Let's measure in circuit what those capacitors say. These are the two same ones that I took off from the bad board. I'll change the voltage to 0.3 volts, so we are sure not to excite the board. And now we measure, and I'll show you what we get. Same cap, same brand. Okay, 115 milliohms and 0.251 dissipation factor. Aha! The second cap, 118 milliohms and 0.269 dissipation factor. So, in fact, between these and these, it's 0.1 of 0.100. This is 0.25 and this is 0.336 dissipation factor. Apparently, this is not so great. Okay, and I can show it to you in another way. I replaced on the board that I repaired, I replaced the caps with another brand. You can see here, these are different. It's from a better manufacturer. Okay, and if we measure again, we get a value. Dissipation factor is 0.199, so it's better. And the ESR is 0.95. These are brand new. So you see, the difference is not that much, but it exists. Here is the difference. This means that the ones on the board, on the other boards, are okay, but maybe will not last forever. Okay, dissipation factor 0.199, 198, and always 95 milliohms. So this might just be from one manufacturer to the other, the difference. What we ought to say is that there is a difference which is very similar on those two in terms of dissipation factor. And probably what we can do is, the dissipation factor is a small number, so you think it might not be so important. But in fact, if you were to test it at high voltage, that's the whole question. Because this is a 200 volt cap. Then you might see a real difference between the good ones and the bad ones. And this is where it all hangs. So a small number in dissipation factor can mean a lot in terms of the way the capacitor functions actually in the circuit at the high voltage. That's why I showed you all this, because in the end you always have to watch also what's the operating voltage that you have, and maybe you have to even test the dielectric at higher voltage to find out if it's okay and if there's no breakdown of the dielectric at high voltage. Some caps, I mean, all the caps will have problems like this at high voltage, and that's why in this case you use another tester. You use a mega ohm meter. That's another test that we can run. But this gives you a little feel of what's ESR and what's dissipation factor on brand new caps, all the caps, and the little differences. And what I'm trying to say is that you do have to build a sense of what's okay and what's not. Tables are one thing, and they give you a basis. Another way of doing things is exactly just how I showed you. Have a little number of caps in the same range of values that you're going to use. You get a feel of what the proper ESR and proper dissipation factor will be in a new component, a new cap, and also between brands, because you can see differences in brands, in size, and sometimes not so much. You see, it's not so evident, but you do see, and you see also from, this is why they have tables, because you can see here, I showed you the difference in the same brand new cap, different voltages and different size of caps, physical size, then give you different results. Voila. So there's no firm conclusion. The conclusion is that you have to build your own experience. Look at the tables, but be careful, and try to think of and submit always your caps closest to the matching condition of the circuit. That's the key also to being sure whether it's working properly or not. If you test, and I will show it on the scope, if you test this cap at 200, which is 200 volts at 1 volt peak to peak, it's going to be fantastic. It's going to work, even if it's bad. Like here, I suspect they're not good. The bulgy ones. The dissipation factor is the only clue we get here. Probably the other clue would be with the mega ohm meter. But I'll show that on the screen they look like a good cap. So this is what I try to make you understand in this video, is that it's not as straightforward as one would think. Just ESR and dissipation factor. None of it is just one single number that will give you a final clue. You have to have a judgment how it works, which voltage you're using. In fact, these caps might still be good if you use them in a lower voltage situation than 200 volts, because they probably have a breakdown point at much higher voltage than the 200 and at 200 volts there. So this is too much for them. They won't work. But that's it. So voila. Just to give you a little idea and perspective and prospective on measurements of capacitors.